Okay, we're going to go over the Physical Science and Engineering final review sheet. I'm going to be going a little bit quick through this, just hopefully at this point this is all review. So, what units would you use to measure the following? Length of a car, meter. Amount of time in a class period, seconds. Volume of a donut, milliliters or liters. And the mass of a book would be grams or kilograms. Next up, we need to convert 29 meters to centimeters. And this one here, I'm going from base to centi, which is going to be 2 to the right. So 29 becomes, move the decimal point 2 to the right, 2,900 centimeters. Convert 0.35 milliseconds to seconds, so I'm going from milli to base. That, in this case right here, is going to be 3 to the left. So take that decimal point, move it 3 more to the left, and I'm going to get 0.00035. Next up, I need to convert 928 kilograms to grams. I'm going to go from kilo to base. That is going to be 3 to the right, so move that decimal point 3 to the right. 928 becomes 928,000 grams. Here's an example of a bar graph. Should be pretty familiar. Here's an example of a line graph. Bar graph is really good for comparison, A versus B. Line graph is really good at one thing over time. Distance between speed and velocity is that velocity has direction. Speed does not, like 3 meters per second. That's speed. If I'm saying 3 meters per second due north, that's velocity. All right, pie graph is really good at looking at percentages or parts of a whole. Steps of the scientific method, these should be familiar, but you have a purpose, you have a hypothesis, a testable idea. You're going to put that to the test in a controlled experiment. You're going to analyze your data, and then you're going to kind of essentially come to conclusions. Go back and double check your hypothesis. How was it? How'd you do? All right, going on to average speed, that should be our familiar equation pyramid, dVt. In this case, right here, I'm looking for speed or velocity, which is distance over time. So 97 divided by 8 is going to give me 12.125 meters per second. Next one right here, I'm looking for distance, which is velocity times time. So 5.3 times 3,000 gives me 15,900 meters or 15.9 kilometers. Instantaneous speed needs to be measured either with a speedometer or a radar gun, some type of tool. And average speed is going to be total distance divided by total time. All right, SI unit or metric unit of force is Newton, capital N. The rate at which velocity is changing is acceleration. That's how fast you get fast. It's not how fast you go, it's how fast you get that fast. Whenever you have an unbalanced force on an object, you have acceleration, whether that's speeding up, slowing down, or just changing direction. All of those entail some form of acceleration, and unbalanced force was acting. If the forces acting on an object produce a net force of 0, those forces are called balanced. All right, so here we're using our equation pyramid for solving for force. Small engine plane causes a 0.8 kilogram model airplane to accelerate at a rate of 16 meters per second. Mass times acceleration, 0.8 times 16 gives me 12.8 newtons. 4 fundamental forces: gravity, electromagnetism, strong and weak nuclear. Force of gravity acting on an object is weight. That is going to be mass times gravity. Remember, if you want to lose weight, just change gravity. You want to lose mass, go on a diet. When you carry an object, how much work is done? None. Force is going up, movement is going to the right. So, not work. Power, that's not how much work you do, it's how fast you do that work. Kinetic energy is the energy of motion. Potential energy is energy that is stored either due to shape or position. An example of storing energy due to shape is like stretching out a rubber band, something like that. An example of energy stored due to position is like holding a weight over your head. That's potential energy. You drop it, it becomes kinetic energy. Law of conservation of energy. Energy can't be created, energy can't be destroyed, it can only be converted between different types, like heat to electricity or vice versa. All right, this one here, some more equations that I'm solving for here. I am solving for work, which is me force times distance. 872 times 152 gives me 132,544. My units are joules. Here I'm trying to solve for power, which is work over time. 274 divided by 13.7 gives me 20 watts. Here's a skydiver falling. Calculating kinetic energy, which is 1/2 mass times velocity squared, so 0.5 times 99 times 22.6 times 22.6 again is going to give me 25,282.62 joules. Now I'm trying to solve for gravitational potential energy, which is mass times gravity times height. As long as we're on Earth, gravity is going to be 9.8. This one here is going to solve out to be 517.244 joules of gravitational potential energy. All right, compare and contrast transverse and longitudinal waves. They both have in common, they move energy from place to place. Now, a transverse wave, if you'll remember, the transverse wave is going to move up and down. The whittle is going to be up and down while the wave itself moves to the right. Where a longitudinal wave is going to actually whittle side to side. It's actually going to move parallel to the direction that the wave travels. So transverse is perpendicular, longitudinal is parallel. Here we are drawing a transverse wave in wavelength. There's the crest, there's the trough, here's the rest position. That is my amplitude, the distance from the rest position to the crest, and there's the wavelength right there. So a longitudinal wave now, that one is like the slinky that's shaking, so I'm going to get those areas where it's a little tighter, that's called the compression, and the areas where it's a little further apart, that's called a rarefaction. All right, some calculations here. 3 times per second. Anytime it's per second, that is your clue. That is going to be frequency, hertz. So 3 cycles in 1 second is a frequency of 3 hertz. That is its frequency. All right, wave has a wavelength of 1.1 meters, so I need to solve for this one here, velocity, frequency, wavelength. Here I'm solving for frequency. Velocity over wavelength, 2.8 divided by 1.1 is going to solve out to be 2.54 hertz. Next one here, I'm looking at 5 crests per second. That is a frequency of 5 hertz. What I'm trying to figure out, though, is the speed, which is going to be frequency times wavelength. 21 times 5 gives me 105 meters per second. That's my speed. Sound is a type of longitudinal or compressional wave, and the sound wave, the frequency, high frequency is going to be high pitch, low frequency, low pitch. Loudness or intensity is going to be a change in the amplitude of the sound wave. Magnetism is caused by the movement of electrons. Here we're going to do a little bit of calculation of it. VIR. I'm solving for current, which is going to be voltage over resistance. 65 divided by 87 gives me 0.74 amps. Electromagnetic induction is the idea that motors and generators are kind of the same thing. You can create electricity through the movement of a magnet inside a loop of wire. A motor puts electricity in and kinetic energy out. A generator is the opposite. Kinetic energy goes in and electricity comes out. Now, when we have that sort of generator